All right, good morning. So my talk today is just going to be a case study or a story. I'm basically just going to tell a story about some of the deployment challenges that we've had at Los Alamos. And I have to believe that this is illustrative of other struggles that people have at other places. So every organization has their own processes and guidelines and all those sorts of things. So this is kind of specific to Los Alamos. But as I said, I think it probably applies to other organizations as well. So while I'm going to tell this as a story, I hope it's not a bedtime story. And we'll see where this goes. OK. So it's not on. There we go. Now it's on. So where does the story start? The story starts at Los Alamos. We have a summer institute that we bring in undergraduate students in computer science, and we have a summer program where they build a cluster from the ground up, and then they run a project on it. And we do that to kind of build a pipeline into HPC, because you don't get a lot of HPC in college. So they learn the terminology, they learn what a cluster looks like and how to build it, and then they run a project on it. So I've been involved with this off and on for many years. And Howard Pritchard and I basically had a project where we were going to study and compare IB-EDR and 100 gig Ethernet, and then we were going to move on to Rocky. So I know some of the pain that you were talking about. But as a lead up into that, when you build the cluster, when they built the cluster, it was an FDR cluster. So the first thing we had to do was swap out all the FDR stuff with EDR. And to help them learn the various tools, we had them compare. So here's FDR, run some IB read-write bandwidth latency stuff. Here's EDR, and look how much better it is. Well, it wasn't. You can see these are the graphs that the students made. So I just took them right from their presentation. And you can see that at very small packet sizes, granted, it was actually worse. And I thought, well, what on earth is going on here? This can't be right. So I went back and looked at some of our clusters. And I said, oh my God, ours is doing the same thing. So we went back and pulled the thread and talked to Mellanox, actually. And Alexei Senin, I have a thank you to him later. He helped me immensely during this summer. What we basically discovered was the institutes was running CentOS 6 something. And if you looked at the Mellanox 5 driver that comes bundled with CentOS, it's quite old. And so the version that, it was one of the first versions that came out. So what we did was we said, oh, well, that's pretty straightforward. We went and got Mellanox OFED and pulled the drivers out of it and upgraded CentOS and moved on. It was relatively a straightforward process. And we were able to do some of the rest of our project. And that was great. So I went and took that information back to say, well, we need to do this on our production clusters, because we do have some systems that use small message sizes. So this matters to us. So basically, the only place we had a production or any real EDR system was in our classified network on some production systems. And so we had all of the constraints that drive and direct our production systems. So some of those are, so what we run on our production systems is old. So this ties back to Jeff's talk from a couple days ago. We have a constraint about what we can run. And I think most organizations probably have that, because they don't want to be bleeding edge if they're in production. So you have to find this balance between what works, don't break it, get some new stuff, but stay stable. I personally feel like LANL's too much on one side of that spectrum. But be that as it may, those are the rules we have. So we were running RHEL 6.x in production. Now, beyond that, we don't run RHEL. We run something called TOS. So TOS stands for Tri-Lab Operating System Stack. And several years ago, DOE HQ said, we want the tri-labs, Sandia, Los Alamos, and Livermore, to run the same stack, because we're tired of you guys all doing something different. So try to coordinate, try to, economies of scale, everybody works together. Primarily, this is built by Livermore. Sandia and Los Alamos can contribute, and they do, but it's usually on the edges. So we're running TOS, which is Red Hat underneath with some things added that we don't always know. I mean, we can pull the thread and find out, but Lustre gets mods, OpenFabrics gets mods, RHEL itself gets mods that come from Livermore. So we have a really different situation. So basically what happened with our systems was when I first built these EDR systems, the version of TOS we were running was so old it had nothing for EDR in it. So I built them with Mellanox OFED drivers. When we upgraded to a little newer version of TOS, we were told, oh, well, we got everything that to run an EDR, a Mellanox 5 card, so we don't have to do all this special stuff. Let's just take what's in TOS. And that's when we lost all that. That's when we went back, actually took a step back and got an older driver. But we didn't know that at the time. So again, the other thing to mention here is, so TOS, at Livermore, they upgrade pretty regularly. I think they upgrade at least 4 times a year. So, but LANL is on a slower schedule for various reasons. And so we are often running a version of TOS that even Livermore may have frozen. They still support it and may be running a few places, but they're not going to do like new patches. So that's the world that I'm living in, right? And like I said, I have to believe there are other places that have maybe different constraints, but they could be in a similar situation. So basically, I was able to, I had a test, I put up a test system, just a standalone server, and I ran on TOS, and I grabbed the Mellanox OFED drivers. Really simple, straightforward. There's a small glitch in that we don't run a standard kernel, because it's a TOS kernel, which is also called chaos, and I think that's funny. And so the kernel name actually says chaos in it. So there's a nice script that comes with Mellanox OFED, and it says if you're running a non-standard kernel, do this thing. I did it, no problem. So that worked fine. The next wrinkle is that where we're deploying this is on a cluster that has diskless nodes, which means as most diskless nodes that I'm aware of, you kind of have a mix. It's called a hybrid. You have some stuff in RAM, and some stuff is NFS mounted from some place, like in our case, the master node. So that introduces yet another complication in that now you have to deal with this hybrid image that has no disk, and you have to have all the right stuff in RAM, so on boot, it will come up. So basically, I got pretty far along with that. The other constraint is we use CF Engine to manage our clusters. So if they go bonkers, we can rebuild them very easily. It's a nice tool. It gives you a lot of benefit, but that also adds another layer of constraint. We have a local repo where you can put local updates, but those updates, unless you beg for forgiveness from certain people, those updates have to be automatic. So if you put an RPM in the local updates, in the local repo, it needs to upgrade automatically. It has to look like a newer version, at which point it'll upgrade automatically. So again, we were able to get through this. It wasn't too bad. So the way the Mellanox OFED driver works is it creates, it puts a file in depmod.d to say, when you want to go load these kernel modules, don't get them from your regular place. In this case, go get them from weak updates. And so we needed to make sure that when our compute nodes booted up, or not the compute nodes, this was done on an infrastructure cluster, which is why we had a little more freedom. When the nodes booted up, if you run a depmod-a and you kind of let the system reconfigure itself, it'll find those kernel modules in the right place, and it'll load them up on boot, and everything works. So that worked. So we had a success. There were a few bumps in the road. They weren't that big. We were able to make it work. We had a couple different infrastructure clusters that we did this on. One of them, actually, Jeff talked about in production. We call it campaign. It's MARFS. It's kind of the same thing. But campaign storage at this point in production for erasure was using something called Scality. And Scality uses lots of really small messages. So they were having trouble with the system and not seeing the performance they thought they would get. When they upgraded the driver, they got a 25% performance increase. So people were really happy. So this was a success. There was a wiki page created. Look what I did. I was trying to point at it. There we go, this guy. So the wiki page here gives you all the instructions, because the other thing that happens is we don't upgrade very often on our production clusters, but if there's a security vulnerability, which they do happen, we have to upgrade. Or we have to take the clusters offline. And sometimes we do that until we get them upgraded. So anytime the kernel has to upgrade, we got to go through this process again. So a wiki page was created so that I wasn't the only one who knew how to do this. Other people did it. That information and knowledge got distributed, so that was cool. So success. But then we had a Lustre complication. So back to the problem with Red Hat being old and TOS being old and LANL being slow. We're like really old. We're running Lustre 2.5. So with Lustre on the systems, some of our systems like Campaign they're not involved with Lustre, so it didn't matter to them. So they were happy. But the systems that mounted Lustre, we then had to rebuild the LND for Lustre. So Lustre, we mounted over IB, so it uses the IB LND. So if you're changing out all the fundamental bits, right, you got to rebuild that as well. We ran into a problem there because we're running TOS, which doesn't run regular Lustre. It doesn't run Intel Lustre. It doesn't run Lustre as you get it from the source. It runs Livermore Lustre, which is fine. They do things that they feel they need to do, and I'm sure it has value. There's a little bit, not a lot of visibility. Don't laugh. Not a lot of visibility from the LANL side into what those changes are. So basically, I had to find the source RPM that came from TOS and try to rebuild it. And so I'm kind of stumbling around at this point. And the failures I was seeing were not indicative that at a first glance, I could find it on Google. So I'm poking around. I actually talked to Oak Ridge, who gave me the advice to go in and manually update the module symverse file. Rip out all the IB stuff and stuff in the new stuff. And I'm like, hell, I'll try anything, right? So I went to my test system, and I tried it. Didn't work. So at that point, I created a ticket with the Livermore folks, and being honest, told them everything I was going to do, or that I had done, at which point the response was, what you're doing is frighteningly non-standard. We can't help you. Close the ticket. So I'm like, OK, guess I'm on my own. Ultimately, I found the answer. A little bit of interwebs Googling, making some connections. Basically, it was a pretty straightforward solution. It just took me a while to get there. And these were some of the things I had to do. So in the spec file, there's these settings on the build that if you want an O2 IB LND, you have to say, yes, please build that for me. But since I was using Mellanox OFED drivers, I had to not just say yes, I had to say, go here for the stuff you need to build. Pretty simple solution. It just took me a while to find it. I put my name in as the packager, so if it broke, they knew who to blame. I had to find and change the release number so that the admins were happy that it would update instead of do anything manually. And then Livermore uses Koji, and so there were some Koji checks all jammed into this. I think it was in the spec file. And we don't use it, and so it was choking when that happened, so I took those out. OK, so almost done. Now it'll build. It'll try to build, but there were issues. So I basically, at this point, I was kind of like, I'm not going to be, I'm going to win this battle. Even if we never do this in production, I'm going to win this battle. So I basically pulled the thread on the errors. They were mostly errors related to defines that were either doubly defined or differently defined. And I think, again, this is the root cause of this is that Lustre was too old. A lot of these changes had already been put into 2.9. They'd been backported to 2.8. But 2.5, who cares about 2.5 anymore except Livermore and LANL, right, and Sandia. So it was a couple of small patches that I wrote, put into the source RPM, and then fine, it builds. I need to mention at this point there was a third patch that Alexi at Mellanox gave me that had been backported into other versions of Lustre that we also didn't have, which had to do with the Mellanox 5 drivers changed the way they did the memory allocation, the fast APR, the fast memory versus fast API. So they changed, and they actually reduced the memory chunks that they grab, and so there had to be a patch that would handle that. So Alexi provided that. It built, we're good, let's move on. So we upgraded several clusters, the infrastructure clusters. And so at the time, I was working on this through the late summer, early fall. It was just a question of performance for really small message sizes, so it was not a high priority or critical. Then came the CTS1 clusters. The CTS1 clusters were put on the floor summer, fall of last year. They are now TOS 3, which is RHEL 7, but still TOS. And they are OPA internally, but our I/O nodes, which are our gateways to Lustre, have OPA on one side and Mellanox on the other, so that we can talk to our Lustre file system and our IB backbone. They wouldn't mount Lustre at all. Same problem, but manifested in a more significant way, because now we can't even mount our parallel file system on these brand new clusters that we just bought. Big problem. Now, the reason this was a problem, again, so there's layers upon layers here, right? And so this is a case study, so not everybody's going to have this problem. But we were running a version of Lustre that was so old that when you have IB-connected systems, they all have to have the same settings in their Lustre, like their modprobe config file. One of those things is peer credits. So your peer credits have to be the same everywhere. In the classified network, we have a Synexian file system, which is part of our brand new, fantastic Trinity file system, Trinity cluster, which is not working yet, but we won't talk about that. So this is like way high visibility. Synexian, we bought this thing. It requires peer credits of 126. That's huge. The default peer credits is like 16. So we had to put 126 everywhere. That's why this wouldn't work. Lustre wouldn't even mount. So we tried reducing the peer credits on the Synexian to say, can we just take them down to 16 and move on with life? No. We did that and did some testing, and we would have lost about a 40% performance from the Synexian file system on our flagship Trinity system. Not an answer. So we had to come up with a new one. In the meantime, while we were trying to study different options, what are we going to do with this? I was like, well, let me just rebuild this thing on 7 like we did on 6, and we'll move on, and life will be good. Well, that didn't work for the following reason, which I didn't pull the thread on, was when I tried to do the same process that I did on the RHEL 6 systems, or I should say the TOS 2 systems, when I tried to do this on TOS 3, when I inserted the Mellanox 5 core kernel module, I got this error. So Pippin is one of my test systems. Mary and Pippin are my test systems. I get this error. So in the memory management subsystem of the kernel, something's broken. I'm not going there. That's beyond me, right? So I call Alexi again. Lexi, it's me. I would open a ticket with Mellanox, and then I would call Alexi, who gave me his direct line, and say, hey, I just opened a ticket, can you grab it? Because otherwise I get, did you plug it in? You need to upgrade, yada, yada. So he knew by then what I'd been doing. He duplicated the same exact process on a RHEL 7.3 system, and he said, I'm not seeing the problem. So this is TOS. He's like, well, you can go through all the kernel patches that came in with TOS and figure out which one it is and see if you can rip it out. And I'm like, not going there. So I basically told management I can't do this. I mean, I can, but the other thing that would happen if I did this is I then have to upgrade Lustre, the O2IB LND, and I have to upgrade the HFI driver because they all rely on the underlying IB bits that I just changed. So it would have been a big cascade of changes anyway, so this became a non-starter. So those were the issues. We wound up solving this a different way, which was kind of a kludge, but it worked, and that was the one system that mounted every Lustre file system in the classified network. We changed that to use TCP LNDs to mount our common Lustre file systems, which allowed us to then break that requirement from Lustre, and then we were able to mount the common Lustre file systems on these CTS1 systems. So that was the solution. Probably not the best solution, but it was the only one we had. So the sequel to this is, so now I've gotten pretty good at this, and I know how to do it. And so Howard Pritchard and I are working on another project as part of the ECP project, bought this test cluster, which we have OPA and Mellanox in the same cluster, doing various tests. Howard's doing a lot of UCX work and stuff like that. But so he came to me and he said, I would like for you to upgrade my drivers on this. It's called Hickok is the cluster. Can you please come upgrade it? And I was glad to do it because then I could prove to myself that it was TOS that didn't allow the upgrade, not anything else. And in fact, that's what happened. I was able to do the same process. There were a few minor hiccups in that, again, with the compute nodes being hybrid and all that sort of thing, there was a small issue, which, and I forgot to mention that on the earlier one, I also couldn't get things to load correctly on boot and had to slowly peel back the onion skin to find out what was the problem. And it turned out that with the new, with the upgraded driver, there was a dependency on configfs.ko, that kernel module, which we didn't have in RAM. So when you're booting up and all your kernel modules are loading, if it looks for something it can't find, it's just not, you're going to come up with a weirdo, situation of what kernel modules got inserted and which didn't. So it took a while to figure out which kernel module is depending on that. And maybe if I knew more about kernel modules and the dependencies and a way to debug that other than just pulling everything out manually and then shoving it in one by one and seeing what fails, that's what I did. So same thing here, wouldn't come up on boot. So I did the same thing I always did. I just rip out all the kernel modules and I put them back in one by one to see what happens. And basically what I found was in the RHEL 7 version, which lots of things changed in RHEL 7. And so far the only thing I like about RHEL 7 is dmessage-t, but I'm sure there was a reason for RHEL 7. And systemd and all that stuff. But so they changed, so the driver, it's changed where you put, so instead of being in weak updates, they're now in extras. That's represented in the depmod.d file, but when I just went to look in weak updates after the install, I'm like, well, where are all the kernel modules? They're not here. They were in extras. But as you watched it boot, the first thing that I saw here was this HFI disagrees about some stuff. So I'm like, well, I must have the new stuff because HFI is unhappy. So I must have the new stuff. And then the next one I see here is there's a key that it doesn't like. It's just a warning. But I never added the Mellanox OFED keys into our RPM database. So it's saying, I just installed some stuff and I don't have the key. So I'm like, it's doing the new stuff. Why isn't it there when it actually boots up? And again, this was another clue, though. Now uverbs is saying, I'm unhappy. So when you upgrade the Mellanox, to go back a step, when you upgrade the Mellanox 5 drivers from Mellanox OFED, you have to bring in also some fundamental bits. You have to bring in IBCM, you have to bring in verbs, and you have to bring in the libmlx5. So obviously verbs was changed. So I'm seeing this mix of stuff. And so basically what I found was that I was pulling in verbs that came from somewhere else. So I pulled the thread on where that somewhere else was, and it came from IFS kernel updates, which is something that comes with OPA. So I found it. On these nodes, we're not using the HFI, so maybe I could have blacklisted the HFI. I'm not sure. I have to go back and think whether or not the HFI kernel modules got inserted. I don't remember. So maybe blacklisting it would have been sufficient. But on this set of nodes, we didn't need the OPA piece, so we just removed that RPM. Just get rid of that piece. There may be other solutions, right? I'm sure there's a defined set of hierarchy, like look at updates first, look at extras next. You know, who overrides who in lib modules land. Maybe there's a way to fix it there as well. I don't know. So basically, I mean, all of these things were solvable, but it took some work. It took some phone calls. Some were, you know, cold calls to people who I thought, hey, I met you last year at the LUG conference, and you guys were doing cool stuff. What are you up to? You know, so that was some of it. So I'm going to blow through the next slide. My husband told me that I should remove it, and I didn't, but he's usually right, so I blew past it. I'm not going to go there. But what I do want to talk about is just the takeaways from this, right? So this is a case study. This was our experience. It may not translate exactly, but I'm believing that it translates in some way, shape, or form to what other people have dealt with. If you're in a production environment where you need a stable environment, so you can't always upgrade, and you have to work within the constraints of your organization. You have to work with your managers who don't always understand the complexity that you're dealing with. So here's the takeaways. First of all, complex systems are here to stay. You know, we're testing OPA and InfiniBand in the same, and I hesitate to call it OPA and InfiniBand. Sorry for those in the room, but OPA advertised itself as the next better thing to InfiniBand. There's a lot of InfiniBand under the covers. There's OpenFabrics under the covers that is confusing when you think you're on an OPA cluster, but IB_blah is all over the place. So that, just from an administrative standpoint, understanding that, I mean, that's fine, that's life, that's the reality, but you have to understand those things so that you don't think, what's this IB stuff in here for? Let's rip it out. Not gonna work. So managers, understand your environment, understand your technical people and listen to them. So if I go to them and I say, we really don't wanna do this, because if I do the Mellanox driver, then I got to do the O2 IBLND, then I got to do HFI. Maybe we can do that, but it's probably not what we want to do on our production systems. We might want to, that's a long-term solution, maybe. Maybe the community will solve it for us, but right now that's not where we want to go. Or on the converse side, for the RHEL 6 systems, this isn't that scary. It's just a Mellanox driver. I can do this, we can support it, don't freak out because it's not Livermore approved. Our management is a little bit like, if it's not Livermore approved, we don't do it, which is a little frustrating. So vendors, don't assume a single technology, don't assume we can just upgrade. Don't be like, well, you need to go to the newest stuff and then we'll talk to you. And get some sense of the skill level of your customer, which goes to the thank you I have here to Alexi. You know, he was willing to give me his direct line because he knew that I had some sense of what I was talking about. And he wasn't going to waste his time by trying to talk to me. And I wasn't going to waste my time by trying to explain it all to the first-line support person who answered the phone. Those are important messages. For admins like ourselves, try to understand the underlying code. You know, I resisted for a very long time, you know, subscribing to Linux RDMA mailing list. Even if you don't understand a lot of what's going on there, and even if at the beginning it makes you like run screaming from the room because you feel stupid, you gotta try and get in there and learn this stuff, because that's how you're gonna make it work. That's how you're gonna optimize it, is by understanding these things on some level. You don't have to be a kernel developer, but understand them. Build relationships in the community. The guy that I cold called, it wasn't really a cold call. I had met him at a conference, and we talked about problems with luster and these sorts of things. So he knew, I knew his face. I didn't know his name, actually. I had to figure out his name. Bad with names. But you know, you're like Todd said in the town hall last night, When you know somebody, when you've had a conversation with them, when you can see their face in your head when you're on the phone with them, you can have a better conversation. So build those relationships in your community. And for developers, try to put yourself in, the administrator's shoes. What are we dealing with? The people who deploy this are a big part of the community. And I think most of us are doing our best to try to understand it. But we have a foot in both worlds, and that makes it hard. So we will never fully be developers and kernel developers, and we may not always understand all those, down to the nitty-gritty detail, but we're doing our best to make it work on the ground. And if it doesn't work on the ground, management and customers are going to walk away from it. So if you want, in my case, if you want your science to get done, it's a good idea to understand these things and get as involved as possible. And I believe that's all I have. That's it. So, any questions?
Yeah, I have a couple, actually kind of addressing the slide you skipped. So I'm curious, you had as much problem in 7.3 as you did for the Mellanox piece, given that I know personally that the drivers in there were a minimum base of 4.5 with a lot of 4.6 and 4.7, which at the time was the latest. So I'm curious what my Mellanox friends are putting in OFED that's not in RHEL. Okay, so that's a little disturbing to me.
Right, let me just comment on that.
I'm going to add 3 things, so maybe
Okay.
you guys can all put the puzzle together so you may know it from the background. Second of all, so Red Hat has this service called TAMs, which are technical account managers, which are basically people that our customers pay us directly, and all their job is to do is service that one customer. You have an LLNL TAM. Believe me, I know his name really, really well. And the case in point I can put in is LLNL complained about a huge P over IB performance degradation that was hit in 7.3. That was because we rebased the code to 4.5, which carried a change that someone made that caused the degradation. Once the report came into us, we put our network heavies into it, and they solved the problem that was sitting in upstream for 5 months.
Okay.
So, A, get your bugs to us. 2, leverage your LLNL resource, and I don't know how you do that. I know you're filing a ticket. Okay. I don't know how that gets all the way to
right.
the TAM, but I know you got one. We have the ability to do it, and I personally know all that code because I did it. So
okay, so 2 things and a couple other things. Hope I can remember them all. So the first thing is I believe when we did this it was 7.2, not 7.3. I learned at that time, perhaps through Doug, I asked some questions about. So of course I was asking Alexi all the time, when is this going to go upstream? When is this going to go upstream? And he said a lot of it had been submitted upstream. Not all of it had been accepted upstream. And what I learned, being new to this, new to some of this, was that just doing a mod info on your kernel module on a Red Hat system does not tell you what's in it. So when I did a mod info on the 7.2 RHEL, once we got it, or TOS 3, it said 2.1 still. When you do the Mellanox upgrade, you get like 3.4, whatever their Mellanox version is. So I was kind of using that as some of my as my clue, and I learned that that's not a good clue. That they're going to pick and choose the upstream patches as they make sense and as they get tested. So some of it may be there, some of it may not, and so you basically have to run a test. You basically, whatever problem you're having, bug or performance, you have to rerun that to see if you have what you need. So that was the first thing. As far as the Livermore and Red Hat issues, we at LANL now have a Red Hat account, which I didn't know about. So again, this is a problem with LANL, right? Communication within LANL. Yeah. Our managers are always like, go through Livermore, go through Livermore, go through Livermore. I talked to Livermore representatives in January of this year, and I was told, well, you can open a ticket with us if you want, but we may just tell you to go talk to Red Hat. So there are no Livermore people in the room, so I can say this, I'm not getting a lot of good response from them. And I've told them that, and we've tried to work on it, and it doesn't, I'm done there. So we have an account with Red Hat. We have an online account. I can submit tickets that way. I just figured out how to do that. So in parallel with trying to build the relationship with Livermore or improve it, we need to be able to go directly to Red Hat as well. So that when we have problems that maybe Livermore's not seeing for various reasons, because that often happens as well, and they can say, well, we're not seeing that, sorry, I can't help you, kind of thing. We're busy doing other stuff. And again, in Livermore's defense, we're often running old stuff. So they're like, we're not going to bother backporting, sorry. So all those things come into play, and so we are looking at going directly to Red Hat. And in fact, I have been pushing, and I was talking to Jeff about this, and Doug, I think. I've been pushing that on our infrastructure clusters, we should not be using TOS. We should be using RHEL. And we just need to convince the management that the whole world uses RHEL with OpenFabrics and Lustre. It works. 3 people on the planet use TOS: Livermore, LANL, and Sandia. There's a benefit there, but there's also a benefit going to RHEL directly.
Right.
So we can choose, and if we have enough expertise to run on RHEL without the help of Livermore, such that it is, maybe on the infrastructure side of the house, the benefits are not there. On the compute cluster side, that's different. They do a lot of testing on the compute cluster side.
Right. So I'm not discouraging working with Mellanox. We work with Mellanox a great deal.
Right.
We have probably the tightest relationship out of all the RDMA vendors with them for obvious reasons. Getting to what we need to do is get to the root cause of why you got to use something in there, and then we can figure out how we can get it to you through RHEL. Now, I'll admit there's some things that if it's new functionality, we can't backport it into an older RHEL. We have to go to a forward RHEL.
Right.
So if you were on 7.2, your slide said 7.3. That's why I was talking about 7.3.
Yeah.
If it's 7.2 and it's new functionality, that's an issue. That will force you into that. But if it's a bug fix, that's something we backport. We have something we call Z-Stream. So every 6 weeks we do an update to that minor release, and they get packaged up and rolled into that. And if there's a timing issue you need, we also do hot fixes through our support group that will give you a temporary kernel with that fix until you get the final Z-Stream that has it in there. So that's all the things you get with that kind of subscription sort of thing.
The other thing we get, though, is if we go to RHEL on our infrastructure boxes, if you tell us, hey, 7.3 has that fix plus a lot of other stuff, we could have the freedom to upgrade to RHEL 7.3 to get all that stuff as tested in a package, and we're not then tied to the TOS releases that the compute clusters do. So perhaps there's an argument. So there's a lot of benefits there, because like you said, we can either do the Z-Stream stuff and all that, or we just have the freedom to upgrade to the better RHEL release that has everything packaged.
Right, and one minor note I want to say too, what we put in RHEL is upstream. Upstream means it's in and accepted, not it's posted up there, here's my best shot at it.
Right.
So there's a huge difference, and there can be some big delays in there. So when we saw that cascade flow that Jason put up, realized to us that doesn't mean it's just floating in there, and we really don't prefer it in a next tree either. We mean in a release, even if it says new like now as in 4.11 RC2, that's good enough for us to pick from.
Right.
Okay? So.
Any other questions or comments? All right. Thank you.